Hi everyone and welcome again to Math 030, and for this succeeding videos I will discuss the equations of lines and planes. So how do we represent a line in a vector space? So given we have given the R naught and then V, we can represent the line L using the vector R. So what are these three things? So if we could imagine, let's say we have 3D space. Okay, so this is your x axis, this is your y axis, this is your z axis, and let's say you want to represent this line L. No? So how do you represent this line L? So we can pick any arbitrary point here that we can call, let's say, uh, uh, P, no? Which is P of x, y, and z, and then we can pick another arbitrary point here which is, let's say, P sub 0, which has a coordinate of x sub 0, y sub 0, and z sub 0. So with these two points, you can actually derive the equation of this line. And how do we do that? No? So we could represent this point P into a vector, which starts from the origin, and let's call this the vector R sub 0. And then we can create an arbitrary, no, again, another arbitrary vector that connects these two points here. And let's call this A for now. Ano? So the A vector is that. And then as you can see, no, we can actually vary this A. So since we already have our initial point P naught, we can vary this vector A by multiplying a scalar T. No? So scalar T, and then let's just call this a multiplication of a new vector V. So the T here represents the changing of the scale of your point. No? So we can represent another point here, for example, for this for just an example, no. So you can vary this T, you can multiply this by T that could vary this from this first reference point into this point P by again multiplying this t. No? So you can change the direction by multiplying a negative t, or you can shorten this vector by multiplying a smaller t, or a greater t will be a larger or a longer vector. So this will be a representation, and as you can imagine, actually, we can add these three vectors, and we can call this our vector R. So to simplify this again, we can see that we have the R sub 0 vector, and then we have this A vector, and then the sum of these two vectors is called R vector. So therefore, the equation here that represents this line is R vector equals to R sub 0 vector plus A vector. And we know that we can change, no, we can tune. No, we have the knob, which is T, which is called actually the parameter, to vary this A. No? So we have R is equal to R sub 0 plus T times the vector V. Okay? And we know that R sub 0 and V here can be represented, no? We can just represent this vector here. Let's just create an arbitrary way to notate this R sub 0 and V. So for R sub 0, we already know the terminal point is this. So we can write this R sub 0 as a vector which has a terminal point of R sub 0, X sub 0, Y sub 0, and Z sub 0. And then for V, for now, we can call this A, B, and C, no, as its elements vector. So therefore, we have R is equal to, we have X sub 0 plus, Y sub 0, Z sub 0, and then plus T, and then we have A, B, and C. And if we simplify this, we can represent this vector R. So we have here a multiplication, no, of a scalar to this. And then we can add this 2 independently, no, diba? Using the addition of two vectors. Therefore, we can say that x sub 0 plus a for the first term, no, times t. And then we have y sub 0, and then we have plus b times t. And then we have z sub 0 times t, sorry, plus c times t. So therefore, the coordinates here, as you can see, the coordinates that represents this r can be broken down into its x, y, z coordinates. So this will be your x coordinate, this will be your y coordinate, this will be your z coordinate, which represents this point, this arbitrary point that we're trying to represent. So using this, we can equate this to x, which is x sub 0 plus at, y is equal to y sub 0 plus bt, and z is equal to z sub 0 plus ct. So take note of these things, and we have a better way to represent that. So remember that our vector r is just a sum of two vectors, r sub 0 and a, in which a can be represented as tv, so that we can turn the knob for t, which is called the parameter, that could change the direction or scale this vector. So we have here the initial point, the reference point, and then the vector v. Okay, and then this is called the parametric equations that represents x, y, z of our line. So how do we imagine this, with regards to our previous topics in pre-calculus course or in your analytic geometry class? So in there, or even in your linear algebra class, is that we could imagine that this r represents this y, and then this t actually represents this x, the varying x, and then this t here, sorry, t here is actually x, and then your slope here is actually v. So y is equal to mx plus, and then this will be your intercept, So this is how I look at this when I'm trying to understand lines. So this is your r, this is your t, this is your v, and then this is your r sub 0. To remember this, So v represents the direction, the slope of this line. X is the variable that we are trying to vary, and then v here is somewhat our reference point, or no, it is not actually the intercept, but it represents some point in this line. Okay, so this is how do we remember this equations. Okay, so let's have an example here. So find the vector equation and parametric equations for the line that passes through the points 5, 1, 3 and is parallel to the vector I plus 4j minus 2k. And then find two other points in this line. So how do we do this? So we want to find the vector equation. So we're trying to find here is r vector is equal to r sub 0 plus tv, right? Which is, how do we do that? So actually, if we could imagine, this is actually your p sub 0, and we can write this again. We can say that this r sub 0 is equal to 5, 1, and 3. Okay? And it is parallel to the vector I plus 4j minus 2k. And this will be your vector. This is your direction. Parallel to, meaning it is your direction. Therefore, v here is equal to this, which is, we have 1, and then 4, and negative 2. So what are this? This is your A, this is your B, this is your C, and this is your X sub 0, Y sub 0, and then this is your Z sub 0. So therefore, to represent this, actually with the vector equation, we can just write this as, we can use this standard basis notation, So we have 5i. So this one is what we are trying to write one, and then plus j hat plus 3k hat, and then plus t times, we have here I plus 4j minus 2k. So therefore, the r vector, so we could just add this independently with each element. So we have 6i, and then we have, sorry, not 6i, but 5i, or sorry, to be exact, this should be 5 plus 1 plus t pala, 5 plus t, and then I, because we're trying to multiply t nga pala dito, And then plus we have 1 plus 40 a j hat. And then we have, so 3 plus 3k plus negative 2k times t. So factor out the t. We have here 3 minus 2t and then k. So this will be your vector equation that represents this line. Now for the parametric equation, basically this is just your parametric equation. So we have x is equal to this, y is equal to this, and z is equal to this. So therefore we have x is equal to 5 plus t, y is equal to 1 plus 4t, and then we have 3, z is equal to 3 minus 2t. Okay. So another question is to find another 2 points in this line. So there is no instruction on what points are we trying to look for. So we can just choose any, no? We can just choose any point here in this plane. So we can substitute any t. So it depends on you, what you want to substitute as t. So let's just substitute, let's say t is equal to 0. So your x here, that will be equal to, so if you substitute t is equal to 0, we have x is equal to 5, and then y is equal to 1, and then z is equal to, so this will be, so 3 minus 0, this is just 3. So this is our first point that represents this, or a point in this line. So another point, we can substitute any value of t. T is arbitrary since it is a parameter. So t is equal to 1. Let's substitute 1 here. So this will be 5 plus 1. So x is equal to 6. We have 1 plus 4t. So 4 times 1. We have y is equal to 5. And then z. So we substitute 1 here. We have 3 minus 2 times 1. So this will be just 1. So this will be your 2 points in your line. So it could be any value of t. You can say you want to substitute 2 or even negative numbers or even square roots, if you want, or any real number. Okay, so now we know already the parametric equations that represents our lines. We can actually create another way to represent these linear equations. When we substitute this, when we manipulate this equation, so we can imagine, let's say, transpose this to the other side. So we have x minus x sub 0, and then this will be equal to at, and then divide this by a. So we can see that t is equal to x minus x sub 0 over a. And if you do this as well for the other parametric equation, you will have the following. So if we equate these three equations, when we say t is equal to t is equal to t, then we will have these equations that actually is called the symmetric equations. So this is just another way to represent your equations. Okay, so another question here, or another problem. So find the parametric equations and the symmetric equations of the line that passes through the points A and B. Okay, so how do we do this? So we have two given points. We want to first find two things. So to find this r vector, which is our line, the vector that represents our line, we can choose any r sub 0, and we can also choose, or we need to find the v. So we want to find this and this one. So to find r sub 0, you can actually choose this as r sub 0 or this one. So any of the two given points can be a reference point, but usually you can just choose the first one. So how do we find the v here now? So to find the v here, okay, so we can imagine that this points, let's say this is point A and this is point B. So there is a vector that represents this A and then this vector B. So that the difference between these two vectors, or actually this the right representation. So we can find this vector V here, this vector here, V, that is equal to the subtraction of these two vectors. So we can subtract these two vectors A and B to get this vector V. So we have these 2 points, and subtracting these 2 points gives us a new vector, which is the line. No, we want to find this line here, this line here. So to find just a slope, no, in your pre-calculus course, you want to find a direction, no. So somewhat this vector represents this direction. Okay, so to find v first, let's first find for v, that is equal to the difference between these two vectors. So we have 3 minus 2. So 3 minus 2 is, so yeah, let's solve this later. And then -1 minus 4, so -1 minus 4, and then 1 minus -3. So this will be 1 plus 3. And then simplify this vector. So 3 minus 2 is 1. 1 minus, -1 minus 4 is -5. And then we have 1 plus 3, which is 4. So this will be your vector now. And again, now we could say that r sub 0 is equal to this. Again, you can make this also as your reference point, but I will just choose this first one again. So we have the reference point is 2, 4, and -3, which is actually also your vector. So to find this parametric equations, if you can remember, the parametric equations is we have x is equal to x sub 0 plus at, and then y is equal to y sub 0 plus bt, and then z is equal to z sub 0 plus ct. So if you can remember, this is actually your a, this is your b, this is your c for your v vector, and this is your x sub 0, y sub 0, and z sub 0. If you substitute this, so this will now be equal to, we have a 2 minus, plus t, and then y is equal to 4 minus 5t, and then we have -3, and then plus 4t. So this will be your parametric equations. It's that easy, no? And then for the symmetric equations, what we can do, if you could remember, we have x minus x sub 0 over a is equal to y minus y sub 0 over b is equal to z minus z sub 0 over c. So we will just write this down again, no? So we have x minus, so x sub 0 here is 2, and then over a we have 1 is equal to y minus y sub 0 is 4 over b, so -5 is equal to, we have z plus, so minus -3, this will become positive, and then c is 4. Okay, so no need to change anything, so this will be your symmetric equations. Okay. So that will be all for this example. And then for an added knowledge, we can actually represent a line segment. So we do not want, sometimes we do not want this infinite line, no, extending from this -t to +t infinity. We just want to find a line segment. We can find the line segment from t is equal to 0 to t is equal to 1 using this formula. Okay, so maybe we will see this again, but just remember this, guys. We have this equation for the line segment. Okay, so that will be all for this video. For the next video, we'll discuss the planes.